Good morning. I just want to go over with you real quickly how to obtain the equation for the maximum or for the velocity, the initial velocity as a function of the angle and the y maximum. So let's go over this. What we want to find the initial velocity or speed as a function of the initial angle and the maximum height. So if you remember, what we have is we have a trajectory like this, where we have an initial angle, let's call it theta, and a height. You need to, on your experiment, you need to make sure that this is level here, but let's call this y maximum, or I'm going to call it just ym instead of y maximum. So that's what we want. We want the initial speed as a function of the measured angle. That's what we're going to measure, and the y max. And so we're going to measure this, and we're going to get an uncertainty in the angle, and we're going to get an uncertainty in y max. So these are the two things that you're going to, the four things that you're going to measure. You're going to measure the angle and the uncertainty in the angle, the maximum height and the uncertainty in the maximum height. Now, one thing about it, these angles, you're going to probably measure them in degrees, but when you put them into equations, convert that into radians and do it in radians. Otherwise, you're going to get messed up on your derivatives. Let's take a look at this. We have the velocity. I'm going to make that as a vector, is equal to Vy in the j direction plus Vx in the I direction. These are vectors there. Now, this is just a constant. I'm just going to forget about this. Let's take a look at Vy. And we know from physics that Vy is equal to the initial velocity times sine theta. Okay, because that's the component going upwards. Let's see, minus gt. Okay, that's just from physics. That's from physics. Gravitational constant there. So we get y as a function of t, then will equal, that's going to be the integral of this. And so that's going to be v0 sine theta t minus g t squared over 2. And you can just get, you did that in physics. The only thing that's new here is this sine theta, because that's the component of the velocity in the y direction. Okay. Now let's look at this. We have, I'm going to define Tm is the time at y maximum. So y maximum, ym equals y when we have Tm. So I'm going to find the time at which it's y maximum. Well, that's going to be when the velocity is 0. So the velocity in the y direction, at Tm is equal to v0 sine theta. Let's see, minus gtm. Again, tm is the time at which we have maximum y. So from this, we can get, let's see, what's that? That's the velocity is going to be 0 when the velocity in the y direction is going to be 0 at y max. So we can get Tm here. Tm is equal to, well, it's going to be 0. So we have V0 sine theta over G. Check out units on that, and you'll see that's in seconds. Okay, so we have Tm. Now we can substitute this back in here, and we'll get Ym, the maximum height that it gets to is y at Tm. Plugging that all in, plug this in for t, and you will see that you get a y max, and I'm not going to do the algebra, just substitute Tm in here, and you will get, let's see, you will get V naught squared sine squared theta over 2g. So that's going to be y max. Okay, now let's put this y max over there, and let's look at this equation. I have v naught sine theta y max, g is a constant. Well, I can rearrange this then. The v naught, the initial speed, is equal to 2g y max. There'll be a square root there. Let's put a 1/2 over that. That's just to make it. Let's see, over sine theta. Okay, so that's my function. That's my function. V0 is equal to a function of theta and y max. So I have that. Now I'm going to erase everything else besides this. I have my function. This function, I'm going to erase this. So we'll see what we're going to do with that. Okay, now I'm going to measure these things, measure theta and an uncertainty in theta. These will be in degrees and then convert them into radians. And y max and uncertainty in y max. Okay, so here's this functional relationship, and let's take an example. Let's take an example. And in this case, I just had y max equals 0.4 meters. And let's say we have an uncertainty in that of 2 centimeters. And we have an angle, theta, an initial angle of, let's say, 35 degrees. Convert that into radians. Let's see, what is that in radians? That is 0.611 radians. Radians, no units on radians. And delta theta is 2 degrees, which is 0.035 radians. Okay, so now plug this and that, this and this into this equation, and we get V0, our initial speed is 4.88 meters per second. Now let's get the uncertainty in this, because we have an uncertainty in our angle and we have an uncertainty in our ym. Okay, we're going to get this. Let's see, uncertainty in our estimated value of initial velocity is equal to df, there's our f function, df d theta delta theta, and square it, plus df dy max delta y max. Square it, and then take the square root of all of that. Okay, so I'm going to let you do that. This is a constant. That's a y max to the 1/2 over sine theta. You plug that in there. I'll just tell you the answer that I got. I got delta theta with these values with an angle of 35 degrees, or do it with radians though, and a maximum height of 0.4 with these uncertainties. I got an uncertainty in my velocity of 0.27 meters per second. What that means is really our velocity is in a range. It's 4.88 minus 0.27 to 4.88 plus 0.27 meters per second. So that's in this range. Let's see. It's somewhere between 4.61 meters per second and let's see, 5.15 meters per second. Okay, so that's what I want you to get. And you'll have to do the work on taking these derivatives. But here's our equation. That was it's a lot simpler than what I reported in class. That was a Monday mess up. At any rate, there you have it. Have a good day.